Good morning, everyone.
Morning.
You know what time it is, right? It's time for us to rub a little DevOps on it and make it better. When I say DevOps, this is what I mean. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. At Microsoft, we internal this sentence. This sentence is literally on our websites. This is how we internalize what DevOps is supposed to mean. And what I'm going to share with you today is how Microsoft has actually taken this and uses it to develop our own software internally at Microsoft. I'm a firm believer that if you implement this correctly, it will drastically change the way that you as a company can implement DevOps and move faster than you've ever moved before. I recently saw a video that I thought really summed up what DevOps can do for your company, what it looks like before it implements DevOps and what it looks like after it implements DevOps. And what I want to do real quickly is I want to share that video with you, and then we can talk about the video after.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. Tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stops.
So when I saw this video, I thought, man, that's like, I've seen companies make this transformation where they go from just swinging a hammer at their code to being able to deploy really, really quickly. So I tweeted this video. What was so funny to me is that a couple people challenged me and said there was no additional value in the second video. Like, how can you say that? Of course there wasn't, Donovan. There were so many more people in the second video. Of course it was faster. Like, I think you're missing the point. And the other person says they didn't refuel the car, so they added no value in the second pit stop. I'm like, holy mackerel, what are you guys talking about? So I'm upstairs and I'm just fuming, like reading these comments. My wife comes in and says, what's wrong with them? Like, they don't get it. I should write a blog post. She's like, yeah, you should write a blog post. So she's like just egging me on and getting me all amped up. So I literally write an entire blog post explaining why this is a perfect analogy for DevOps. And what I'm going to do is I'm going to talk to you just a couple of the points. The increase in the number of people. I started at a company called Compaq Computers, if any of you are old enough to remember Compaq Computers. All the old people are laughing right now. So I've been around a really, really long time. I remember when I, as a developer, would write software, and when I was done, I would go over to the actual production server and type in my own credentials. And it would log in, and I would copy files, change the registry, do whatever I wanted to that machine. It was me and the machine. That was all the people involved in deploying software. Is that the way it is today? No. There's you, QA, project management, auditors, the ops team. There are more people today involved in deploying software than there ever have been in the history of our industry. So to me, this is a perfect analogy of what it used to be like when I deployed software and also what it looks like today. And I was swinging a hammer because most of the time I broke the server when I was done, right? Not only did my software not work, but no other software on there worked either. It was like a horrible mess, but that was how I deployed software. But what I thought was even more interesting is when I saw all those individuals there, I didn't see them as people. I saw them as automation. I saw them as all the little things that we do to create a DevOps pipeline. Continuous integration, continuous delivery, infrastructure as code, configuration as code. I just saw DevOps best practices around this process to make it go much faster than before. So it was interesting how people saw them as people when I saw them as automation and the things that we're trying to do to make us more efficient. So let's talk about refueling the car. If we watch the first video again, you'll notice that he's done filling the car halfway through the pit stop. The other 37 seconds is trying to change the other tire, right? So refilling the car is not the most painful part of this process. The most painful part is changing the tires. I've always been taught you should fix what hurts most first. What hurts most is changing those tires. So let's fast forward in our mind. If you fix what hurts most first, what happens? Something else becomes the most painful part, right? So once they figure out how to change not only 2 tires in 67 seconds, but all 4 tires in 3 seconds, all of a sudden, that person filling the car, they're the bottleneck now. How do we fix that? If you're asking yourself, but they didn't refill the car, you're missing the whole point. It was that they did not have to refill the car. That is a drastically different statement. If that car needed fuel to finish the race, they would have put fuel in that car. But they shifted left. They put all this technology up front. They made the car more efficient such that they could finish the race on 1 tank of gas. Because when it became the bottleneck, they went and they invested. So that instead of doing a long 67-second pit stop, they can do things like this. Every time I watch this video, I see another way that it's a perfect analogy of how applying DevOps to your organization will turn you from the first pit stop into the second pit stop. Now, the reason I show this is because I think it crystallizes the power of it. And that's exactly what we did internally at Microsoft. We took a product that used to take us 3 years to ship, and now we ship it every 3 weeks. 3 years to 3 weeks. Lots had to change. Our people had to change. Our processes had to change. And the products that we use had to change. How many of you remember TFS 2005? Anyone remember? Any brave souls in the room installed it? Did you install it yourself or did you hire a company like mine? Right? It was so hard to install that my first job in this industry was to go and install TFS for you because it was that hard to get going. And even after I did, there's a chance your reports weren't going to work. Right? The reporting services never worked quite right. And it took us 3 years for us to write that. Funny little tidbit. It says TFS 2005, but it didn't ship until February of 2006. Because we were a waterfall company. We knew that if we did 18 months worth, well, we knew if we did all the development and testing correctly, we'd hit 2005, everything would be great. So we developed for 18 months, heads down, nonstop. And then it took us another 18 months to get it to anywhere where you could actually use it. That is now February 2006. Why we didn't call it TFS 2006, we'll never know. But we kept the name the same even though we shipped 2 months later than we were supposed to ship. And then we went away for 3 years, and we came back with 2008. Not much better if you remember, right? About the same product. And it was only good if you were doing .NET on Windows. And only if you were doing plain vanilla hello world file new project .NET on Windows. Because if you did anything else, it became very, very painful. And we realized, okay, 3 years, it's way too long to be gone. We got to tighten this up a little bit. So we went to 2 years instead. 2 years in our industry is a lifetime. Can you imagine all the innovation that was going into Jenkins, all the innovation that was going into Jira, while we have our heads in the sand for 2 years, thinking that we knew exactly what you needed 2 years in the future? Like we had this crystal ball that told us exactly where you needed to be 2 years from now. Nope. We had no idea where we were supposed to be because when we woke up in 2010 with this next product, it was not where it needed to be. And we realized that if we keep doing this, there's no way we're going to be able to stay relevant and be able to produce products that our customers actually need. So we went down to 1 year. Still not fast enough. I know it looks like we made a mistake, but instead what we actually did is we started shipping every 3 months. We took a product that took us 3 years to develop, and we started producing it every 3 months, and we still do this to this very day. If you're using the TFS product on-prem, and like I said, I'm sorry about 2005, but it's awesome now. Right? 2018 is a brilliant piece of software. We give you updates every 3 months. But when I started talking, I said we do it every 3 weeks. The reason why is because TFS is something that you install yourself on your own hardware. It has a twin product called VSTS, or Visual Studio Team Services, that we host for you, that we update every 3 weeks like clockwork. We use our own products to deploy that product. Matter of fact, VSTS is planned, tracked, built, and deployed using VSTS. Back in 2005, you were using TFS, but we weren't. Right? How horrible is that? That we would write software for others that we would not use ourselves. And when Satya Nadella took over, he mandated that all of Microsoft is going to be using one engineering system. And that engineering system is going to be TFS or VSTS. Take your pick. That's when it started getting a lot better. That was about 2013, 2014. TFS started getting really good because we had to support Windows, we had to support Office, we had to support Xbox. These are some of the biggest customers we're ever going to get are actually our own internal projects. And the product got a lot better, and actually Windows uses TFS or VSTS, and the VSTS team uses it as well. So it's really good to dog food our own stuff. We'll talk a little bit more about that as we go along. So we are a Scrum organization. How many of you believe that you are Agile or a Scrum shop? A couple of you? I say believe because every time I start asking you hard questions, I quickly find out that you're not, right? So do you do daily stand-ups? Well, sometimes. Well, then you're not Agile, right? Do you do sprint reviews? Well, only if we have something to show. Okay, then you're not. You're faking it, right? Just because you're running in sprints and you're not doing the ceremonies does not make you an Agile shop, right? And it can be very difficult to become Agile when your management and your leadership don't get it. Because they're going to give you lots of pushback and lots of resistance. They want Gantt charts. They want milestones. They want what they've been doing for the last 20 years. And Agile simply does not work that way. So if you're struggling, I bet it has a lot to do with the people above you still wanting those old relics called Gantt charts that are out of date the second you click save in project. They're out of date already. So what we wanted to do is make sure that our organization got it. And luckily for us, and I got to remember, everything that I'm going to say to you is very unique to Microsoft, but I believe a lot of it can be applied to your company. We are a software company, so you don't have to convince us how to write software better. But if I go to an automotive company who builds automobiles, me talking about Agile is a total waste of time for them. They know how to do waterfall. It works great for making a car, so why can't we apply this to writing software? Right? That's the logical explanation. So when I go in and try to have this conversation, it's very painful and very difficult. But luckily for us, we are a software company. Developers writing software for developers, so this was a very easy conversation for us to have. And we knew if we didn't do it, we were going to lose. I'm a firm believer that there is only two choices in DevOps. You either implement it or you lose to your competition that does, and we were not about to lose. So we decided to implement it instead. So why do I have this chart up here? If you understand Scrum or Agile, there's usually a product owner who owns the product backlog, which is a list of everything that you want your product to do, and it should be in priority order. And then you have the Scrum team, as a Scrum master and the engineers that turn your software into reality. That's exactly what we do. We take one person from our program management team and 8 to 10 individuals from our engineering team, and we make what we call a feature team. VSTS has 50 feature teams working on it at any given time. They're all merging into master every single day, producing over 600 pull requests and running tens of thousands of unit tests on every PR. It's massively scaled, right? So you can definitely learn from some of the stuff that we're doing. One of the things that we found that was crucially important is that the teams sit together. All 50 teams as a team sit together, but all 50 teams do not sit in the same area. What I mean by that is we have teams in Hyderabad, India, we have teams in Raleigh, North Carolina, and we have teams in Redmond, Washington. All 50 of those teams are working on the same product. And if you're on one of those teams, you sit with the rest of your team members. This is crucially important for us because when it's time for your daily stand-up, you just stand up. You answer the questions. What have you done since the last meeting? What are you going to do before the next meeting? And is there anything stopping you? And when you're done, you just sit your butts back down and get right back to work. If I need to talk to this individual about an API that they've written that I'm trying to use, I don't have to find them on Slack. I don't have to schedule a meeting. I don't have to find them on Skype. All I have to do is turn my chair around, have a conversation, and get immediately back to work. The collaboration is unparalleled when you're this close to each other. Okay? This seat that's empty is where the program manager actually sits. They sit with the Scrum team, such that if there are any questions about the future, any questions about product backlog items, they can get the answers that they need instantly. The only reason that that seat is empty might be off at a meeting. Now, what's really important here also to note is that this room has 2 other smaller rooms right outside of it called focus rooms. That way you don't have to have a long conversation or a spirited debate over architecture and distract everyone else in your room. You can go off, go into a room, close a door, has whiteboards, it has conferencing information and equipment. So if I'm in Raleigh, North Carolina, and I need to talk to a team in India, I can go into this room and have a nice conversation, Skype with them, do whatever I need to do. It's really powerful. Another thing that's really important about these rooms is each one of them has their own culture. At Microsoft, we have something called aligned autonomy. What we mean by that is they're autonomous teams. They're completely self-managing. We treat them like adults, and they act like adults. You treat them like children, they will act like children, right? So we give them the freedom to do whatever they need to deliver every 3 weeks. If that means doing test-driven development, they're free to do so. If you want to do paired programming, knock yourself out, right? We do not dictate that everyone has to program the same. Every one of these rooms has their own culture. Some of these people are wearing headphones. Some teams don't like that. They always want to be able to yell out at you and get your attention. Some teams let you eat at your desk. Some teams do not. The team room that I was in, we couldn't take a picture of it and show it to you. Let's just put it that way. Because when you went in there, I remember the first day I went in there, I'm like, I'm stepping on something. Like, what am I stepping on? And I pick one of these little things up, and there are Nerf bullets. You know what Nerf guns are? So the way that they blew off steam is they would just start randomly shooting at each other, and a war would break out in this team room. But that's the culture of that room. That's how they broke stress. So you had to come in there strapped, because if you didn't have a gun, you were the one getting shot at, right? So it was really important. But it was really neat that that room had its own culture, and every room actually had that. So what we allow our team members to do, if you don't like getting shot, is every 12 to 18 months, we let you pick another team that you might want to go work on. Because you can only write Git code for so long, right, before you just want to go crazy. And it's like, okay, I got to do something else. So what we do is we do something called a yellow sticky exercise. The 50 team leads get up and talk about how Git is the coolest thing in the world and you want to work on Git for the next 12 to 18 months. No, work item tracking is cooler than that, and we're going to go work item tracking for the next 12 to 18 months. The developers then literally write their names on yellow stickies, and then they put their first and second and third choices underneath the teams that they want to go on. 80% of the people go back to the team that they're on. They understand the culture. Naturally, we don't like change, or they might like the team that they're on, whatever the case might be. And 20% of them roam around, which is really powerful because it helps us share the information. But if you switch teams, you also switch where you sit, because you got to sit with your team, which is really powerful as well. So we run 3-week sprints at Microsoft. If you've ever gone through a process consulting practice, your sprint length has to be for your team. You don't pick 3 weeks because Microsoft picks 3 weeks. I've worked with stock trading companies where the sprint had to be 1 week long. You can't make a decision in the stock market 3 weeks in the future and expect it to be right 3 weeks later, especially with the knucklehead president that we have. That fool will send out a tweet and the whole stock market will crash, right? And I have to be able to respond to that, like, quickly. So when I worked with stock trading companies, our sprints were like within a week. Like, they were really, really short. When I work in medical software, I can't get the doctor to come to our sprint reviews any more frequently than 4 weeks. So we had a 4-week sprint, right? For us, we picked 3 weeks. And it's called the Goldilocks syndrome. Do you guys have Goldilocks, the little children's book here? Right, so the way I asked him, because I wasn't here when they chose 3 weeks, I'm like, so how did you get to 3 weeks? I know what I do to get to 3 weeks. He says, well, Donovan, honestly, we call it the Goldilocks syndrome because we tried 2 weeks, and it felt too small. And then we tried 4 weeks, and it felt too big. And then we tried 3 weeks, it felt just right. And I'm like, cool. He's like, yeah, Donovan. Like, if you look at the ceremony and you look at the work we were able to get done, 3 weeks was the sweet spot for our team. And we've been sprinting at that sprint length ever since. And they're going to keep doing that. But you might notice that some of these overlap. And why do they overlap? 3 weeks is the actual sprint length. Our deployment takes about 10 days now. But it's completely automated. But so we don't stop sprinting so the deployment can go out. We keep sprinting 3 weeks after 3 weeks after 3 weeks, and then what we do is we pill off a couple of our team members, and they basically babysit the deployment for us. So what we do is we remove them from our total capacity, because we got to give them time to fight fires, get bug fixes into the release, and make sure that the release goes as smoothly as possible, yet we still have other people working on new features. So every 3 weeks, we are going to ship new performance improvements, bug fixes, and features, yet we still have to have some capacity to handle any issues that might arise during our deployment. So it is a completely automated deployment that we use. And we take this 3 weeks and we break it down. The first 2 days there is usually where we harden our sprint goal. We make sure that we have all our tasks broken down. We have really good solid estimates. And then we sprint for 3 weeks. And then at the end, we're done. And then that deployment automatically happens. But you'll notice there's no gap. We simply start sprinting the very next week, and we just keep on going. Okay? One of the things I like to mention about this is that you have to find times to celebrate. If all you're on is on this 3-week death march and you never take time to pat yourself on the back and say congratulations for a good job, this can be monotonous and can get old really, really quickly. So even if you're sprinting and you're doing really good, take that time to say thank you to your teams, pat them on the back, and make sure that they understand that they're appreciated. Otherwise, this becomes really, really painful. You got to find those times to celebrate. That being said, How do we then communicate across 50 feature teams that are in different time zones on different continents? Because I can't be in 50 stand-ups. I can't be in 50 sprint reviews. I can't watch all this cool software being produced. So believe it or not, we use email. At the beginning of the sprint, I get 50 emails that basically say, this is what my team intends to deliver 3 weeks from now. And then 3 weeks from then, I get another email basically saying, this is what my team was able to complete, and here is a 3 to 5 minute video of me actually showing you the software. So it's essentially a way for me to virtually sit in all 50 of the sprint reviews. One of the things that's really interesting about the video, which we did not expect, the video was just there so that I could see the software. But it's a forcing factor for the teams. What's in that video has to be working software. You cannot use Photoshop, you cannot use After Effects, you cannot fake any of this stuff, right? This has to be real working software. So to produce the video in time for the last day of the sprint, when does the software have to be done? Before the last day of the sprint, right? It actually forced our teams to get stuff done sooner so that it could be part of the video, which also gave our program managers an opportunity to review the software before it ever got shown to the general public, which was really neat. So we didn't expect the video to have that effect, but it's really interesting how it's forced our teams to get things done sooner so that it can be reviewed and it can be made part of that video so that it can then be shipped out to our customers, which is really cool. So this is what it looks like. If you've ever used TFS or VSTS, you recognize this right here. This is literally just a query saying these are the items that we intend to work on. If I'm interested, I can click on any of these links and be taken right to the work item, read the details, see how it was groomed, see the estimates, see when it's supposed to be deployed, everything. And then 3 weeks later, I basically get another email saying this is what we were able to accomplish, and here is a video that you can watch showing you exactly what the software does. And this is how the teams are able to keep in sync with each other. And if I watch one of these and I have feedback, I'm free to respond to this email, send feedback to the program manager, get that feedback incorporated in their backlog so that they can go back in and make those improvements going forward as well. So this is how the teams stay in sync. There's another thing that they do to stay in sync that I'll talk about here in just a second. So how do we do planning? We still plan at least 18 months into the future. So what the leadership does, so this used to be Brian Harry. Unfortunately, Brian Harry is no longer with us at Microsoft. He went on a hiatus. So it's now Nat Freeman and his direct reports. They're the leadership that guide and own TFS and VSTS. What they do is they stand and they say, 18 months from this very moment, where do we believe VSTS and TFS need to be? What features do we believe it needs to have? And they look at what our competition is doing. They look at what the industry trends are. They look at what's hot in Azure. And they figure out where do we have to be the best DevOps offering we can 18 months from this very moment. And they plan that out. Now, if we only do 60% of this, we're going to be happy 18 months from now because the world changes, our requirements change, and Agile is all about inspecting and adapting to what you see. So you can't blindly put on blinders and just code all that stuff 18 months straight, not realizing that 6 months from now, a lot of this could be a different story. So that's why you see this 6 months here. We create 2 6-month seasons. One season ends at Build. Did anyone watch Build? A couple of you watch Build? Okay, great. So Build is a really big conference of ours where we make big announcements. And one of these 6 months period ends at that conference. Has anyone ever heard of a conference called Connect? It happens every year in New York. That's the end of the other season. So we basically break down what we want to deliver at Build and what do we want to deliver by Connect. And then we have these big conferences and we make these big announcements. After we've sprinted for 6 months, we basically say, okay, we've learned over the last 6 months a lot of good information. Our competition have made some advancements in their software. The industry has changed. All of a sudden, Docker's hot. Kubernetes is the way everyone's going. Let's take that information that we've learned over the last 6 months and then guess where do we need to be 18 months from now, right? We don't stick to our last 18 months decision. We refresh that 18 months decision every 6 months based on what we've learned and what the industry is actually telling us to do. So that's how we do our long-term and our short-term planning, and we basically sprint every 3 weeks going forward. Now, one of the things, if I break this down a little further, we have this 3-week sprint, we have the 6-month season and the 18-month scenario, but what I didn't talk about was this one. Every 3 sprints, related teams have another meeting of just the leads to talk about what they're working on. I had the privilege of sitting in on one of these meetings for the work item tracking team. That's run by Aaron Bjork. Aaron owns the Kanban board, the product backlog, all the work item tracking integrations, how it works with source control, the whole 9 yards. And these teams obviously are related to each other. So what he does every 3 sprints is he buys pizza, he has all of his leads come into one room, and they basically talk about where they intend to be 3 sprints from now, right? So basically 9 weeks. Where do you intend to be 9 weeks from now? So I asked him if I could sit in on one of these meetings. He dialed me into the meeting, and it was really interesting to see it happen because one of the engineers says, okay, so this is what we plan to do in the next 9 weeks. We have this idea for a new widget. The widget's going to look like this, and it's going to achieve this particular goal. And another lead said, hold on, I had an engineer write that exact same widget a week ago. Why don't you have your engineer talk to my engineer? Had we not had that meeting, we would have 2 identical widgets inside of VSTS where we're tracking bugs and everything. So people talk about, how do you collaborate? How do you share code? You meet with your peers, right? And we force this meeting every 3 sprints to make sure that everyone is on the same page. We're not duplicating work. We're able to use the advances and the knowledge and the experience of everyone else on our teams as well. So I encourage that a lot. A lot of people say, well, Donovan, what if you have a team in Raleigh who's responsible or relying on something in the teams in Hyderabad? We treat them like adults. If you need to have a conversation with that person and align your goals in your schedules, then you need to have those meetings. We're not going to micromanage you. Again, aligned autonomy. Treat them like adults, they'll act like adults. So don't micromanage them ever. Actually, not even, just don't do that. It's horrible. Yeah, no one likes to be micromanaged. So let's switch and talk a little bit about quality. How many developers, true developers, do I have in the room that sling code for a living? Have you guys ever heard of the term code freeze? Right? What does that mean? That means please stop typing. Because if you keep typing, you keep writing bugs, right? And what we have to do now is stop and count all the bugs you have. That is what a code freeze is. It's a polite way of saying, go buy pizza, go have a party, so while we count all your bugs. And that's exactly what we used to do as well. You remember, we coded for 18 months on the very first version of TFS. You know how many unit tests we wrote? 0. You know how many manual tests we wrote? 0. We coded heads down for 18 freaking months. And all the developers patted themselves on the back, threw their code over the wall, and this technical debt just came raining down upon us in the form of bugs. And we had to go clean those bugs up. And that's exactly how, we're not the only people who do this, right? Anyone who's heard of the word code freeze knows exactly what happens next. Then you do what we call a bug bash, where you basically take all those bugs and you try to fix as many as you can. So what you're doing is you're bolting the quality onto the product after the fact. Right? You write it optimistically, the QA team goes and breaks everything, and then you bolt on the quality. But if you change your mindset, you can actually design the quality into the product, right? And it makes your life a lot more pleasant. So this is what it used to look like for us. This is an actual chart. It's very hard to plan when you get these weird peaks and valleys that you don't know when they're going to come. You don't know how big the peak is because you haven't been testing. You don't know until it comes back to you. And if it's not consistent, how can we ever be ready to ship? Buck Hodges is the director of engineering at Microsoft for the Visual Studio Team Services team. He decided that he always wanted to be 1 week away from shipping. That means at any point he should come in on Monday and say, that's it, I want to ship on Friday, and we better be able to pay down all the technical debt we have by Friday. We could never do that if we had a chart that looked like this, because we have no idea how much technical debt we had. But we had to change our mindset. Remember, we had to change the people, we had to change the process, and we had to change the products. This is where we had to start changing our people drastically. He didn't want this anymore. He wanted this. So we had to start doing unit testing. We had to start putting in the test ahead of time. We had to start designing the quality into the product. That way we knew how many bugs we were actually carrying at any particular time. He did some math and realized that his developers could clear 1 bug per engineer per week. So they could never have more than 5, right? Or per day, excuse me. So it's 1 bug per engineer per day. So you can never have more than 5 bugs per engineer. If you had 6 bugs, you had to stop what you were doing and pay down that technical debt, because we wouldn't be within 1 week of shipping if your team had more than 5 bugs per engineer per sprint, right? So that's the way that he started figuring this stuff out. So what we do is we track this very, very closely. Because we know how many bugs we have because we're using Team Foundation Server or we're using VSTS, we can see how many bugs people are carrying. Let me zoom in a little bit for you on this one. That highlighted area is the bug bar, as we call it. And your team should be below 5. If it's above 5, that's a problem. I'm going to kind of pause for effect here because what I'm about to say is extremely important. You cannot punish your team for these numbers. Okay? Does everyone understand what I mean? We want you to measure this. We want you to track this so that you can inspect it and you can adapt it. If you punish people for being above 5, engineers are very smart people. Magically, all the numbers are below 5. Not because they're supposed to be below 5, but I don't want to get in trouble. So magically, I'm just not going to report issues. I'm not going to report bugs. I'm going to game the system and always be below 5. I swear, I think one of these teams might have already been doing that. I don't know how you get 0.73 bugs. I've never seen a team that good, but hey, we're going to take their word for it. We do not punish with these numbers, but we do go have a conversation with the teams who struggle to go below 5. Because we have to help that team succeed. If you can't stay below 5, as leadership, it's our failure. We haven't equipped you with the right information. Maybe you were working on technology that we didn't get you properly trained on. Maybe it's because you can't run your unit test fast enough because your build machines are too small. There's a reason that you failed to stay below that number. And what we need to do is identify that reason so that we can go back in and help you correct it. But do not punish your engineers for these numbers, because it's really important to measure so that you can know if you're making improvements or not. Now, whenever I do this talk, a lot of people are like, well, all you've talked about now is the development side, though. It's called DevOps. Where does the ops side come into it? Well, we also have what we call an engineering scorecard. Now, this is not just the ops team. This is also responsible by the dev team. One of the mantras that we have at Microsoft is, if you wrote it, you run it. That's a huge mind shift change for a lot of people. What I mean by that is, historically, I would write the software after I couldn't touch the servers anymore, because there was a time I could touch the servers, then I kept breaking them, then they said, Donovan can't touch the servers anymore. So then what ended up happening is I would package my software and I would write a Word document, and I would give that Word document and the software to an ops person. And the per ops person now had to go read my doc and try to install my software. We all remember that. That was the next logical stage. Get Donovan off the box, right? So that's back when we had this clear separation of concerns. I wrote it, I gave it to you, and I went to sleep, and I didn't worry about it anymore. All night long, this poor person is trying to install my software. They're cursing my name, but I sleep nicely through the night. They finally get it installed. The software doesn't work. They're getting service calls like crazy, but I still sleep peacefully through the night. I wake up in the morning. I might have a bug assigned to me. I might get to it today. Maybe I don't, right? And the next night, that poor person lives hell again while I sleep through the night. There has been zero consequences for my bad decisions. So I'm going to keep doing what's easiest for me, and I get to sleep through the night. But guess what happens when the system goes down and we wake your ass up? Quality goes through the roof, right? Because people are like, I want to sleep. And you mean to tell me that if I write bad code, I have to wake up in the middle of the night? Okay, let me go start writing some unit tests, right? Let me go start testing the software a little bit more aggressively, because I'm the person who's paying the consequences. If you wrote it, you run it. So this is not pointing fingers at the ops team. This is actually measuring how well our ops and our dev teams work together. What we're measuring on this thing are, for example, how many LSIs, which stands for live site incidences, did we have over the past sprint? How long did it take us to even detect that there was a problem happening in our system? Was it our telemetry that caught it? Or was it an email from a customer complaining about the system not working? Once we identified it, how long did it take us to resolve it? How long did it take us to mitigate it? And how long did it take us to put the long-term fix in? That's what we're measuring on this board. You'll notice there's quite a bit of red on this one, but we did not punish anyone for that red. We went back and said, why did this take so long? Why were we not able to make this green? How do we go and enable you to make this green? And we all work as a team. This is team ownership on how do we make this green and not red. Do not punish with these numbers. I simply cannot stress that enough. Otherwise, all these numbers would be useless, and measuring it would not be important for us at all. But measuring is crucially important when it comes to implementing DevOps. If you remember the very first definition I showed you, I think the most important word in there was value. It was not about shipping software. It was not about shipping features. It was consistently shipping value. Do I know if I shipped value just by copying files to a server? No. If I add a couple cool pages to my website and I FTP them out to the server or however you want to deploy it manually, and no one sees those pages, did you deliver value? No. You just copied random files to the server. But you have to monitor the app while it's being used in production to determine if you actually delivered value or not. And that's really, really important. Because remember, when we talked about Scrum and Agile, you're supposed to use the product backlog, which is supposed to be in priority order. Well, if I do the most important thing on the top, but I don't measure, do I even know if the priorities of these items are right? Because if I do the number one thing and we ship it out there and no one uses it, maybe we need to go rethink the priority of everything on our product backlog. Maybe we need to try another experiment. Maybe we need to move some of that to the bottom and something else to the top. Let's go deliver that and see if we move the numbers on here. Just because the numbers don't move doesn't mean it wasn't valuable. Could be non-intuitive. Maybe there's something else blocking it. Maybe they're distracted. Maybe your UI needs a refresh. But if you measure it, you can then go run an experiment. Let's put up a pop-up or a toast that tells people about this new feature and see if we can move the needle on the value of this particular item. But if you don't measure, you're just guessing. And it's really important not to guess. And that's what we're doing here. We're not guessing on if we're doing well. We're measuring to make sure that we're doing well. And if not, we can go and perform an experiment. We can try some new things. And we can see if more of this turns green than red. Understand the point there? Measuring it is really, really important. So let's talk a little bit about some of the different things that have happened. We went from a multi-year cadence to what we call cloud cadence. We're moving as fast as we possibly can now. We're no longer strapped by the box product, stamping out DVDs, trying to ship that stuff to you. Those days are gone. It's about consistently delivering value. Now, one of the ways that we had to do that is we had to go to what we call a live site or implement DevOps to be able to do that. You can't have an 18-month window. You can't have 4 days to test your software. You need that stuff to be constantly being ready, which means you develop in smaller chunks, you test it, and it's done. Right? There's no it's done, but we still need to do X, Y, and Z. Then it wasn't done. Right? It needs to be ready to ship 3 weeks from the time that we say we're going to actually be able to ship it. And we do that quite a bit at Microsoft. When we went from an on-premise product to VSTS, it changes the way that you monitor the code. It changes the way that you debug the code. It literally changes the entire process. So remember I talked about people and process. We had to change them both to move from a box product to an on-site product or online product, excuse me. We used to have a QA team. We no longer have a QA team. I am not recommending that you go back and you fire your QA team, all right? Let me explain to you how it worked for us. Back to Buck. Remember all the technical debt, the code freezes? We not only had manual testers on the other side, we also had automation engineers. These were other developers who just wrote the automation to test our application end to end. We had about 27,000 automated tests at our highest point. None of those automated tests ever passed 100% of the time. Not one time in the history of their existence did we run all those tests and they ever all be green. So as a developer, do I even care? Right? That's just noise to me. I don't know which one failed, but one always fails. I'm not even listening to that anymore. Right? So they're expensive, they're hard to maintain, they're slow to run, and no one was listening to them anyway. So we had to have a mind shift. And Buck said, why are they so hard to write? That was his first question. It's like, well, I don't understand why this automation is so difficult to write. He says, because your developers are writing code the easiest way, but not always the easiest way for us to test. So what we're having to do is write several iterations of the exact same test just to get into all the nooks and crannies of the code. He says, well, why don't you just change the code? He says, that's not my job. And he said, okay, that's a problem. Because if the developer who wrote the code saw that it was hard to actually test, they would simply rewrite the code to make it easier to test. Right? That's the logical thing to do. You wouldn't sit there and beat yourself up trying to write all these weird tests. You just realize that if I change this, it would be much easier for me to test. And he wanted that to happen with everyone on our team. So what we ended up doing is saying, okay, automation engineers, you got two choices. You either learn how to write software on the product and take ownership of it, or you go find another team in Microsoft who needs automation engineers only. Oh, yeah, by the way, developers, you're not off the hook either. You are now also responsible for the quality of the product in which you write. You no longer get to just write the code and not write the software, the test, just test it as well. So now you have to write unit tests. Now you have to own the automation that we're actually writing. And the quality, again, went through the roof. But another problem with automation testing is that the fact that it's slow and it's fragile. So what do you want to do is you rather write unit tests if you can get away with it. Unit tests are fast, they're easy to maintain, and they're really, really reliable. This is another really important part of this talk. Implementing DevOps is not about just getting tools in place. It's not about just building the pipeline. You sometimes have to re-architect your software such that you can move at the speeds you want to move. When we all started programming Windows forms, you double-clicked on the button and you went to the on-click method, right? And then you typed in all the code in the on-click method. The only way to get to that code is to click that button, which means to test it, I need automation to fire up my UI, get to that page, and click that button. But what if I had taken all that logic and put it in a class library instead, and simply called that class library from the on-click method? Now, I can actually test that code with a unit test and verify that it works much quicker and more reliably than using automation. So we had to rethink the way that we had written our software. We had to go back in there and re-architect it such that we could move at the speeds that we wanted to move from a testing perspective, from a deployment perspective. Multiple times we've had to go back in there and rethink that. So please don't think it's all about getting TFS installed, getting VSTS installed, and setting up a pipeline. You might have to go rethink the way that you do your software. And we did the same thing when it came to our dev and our QA teams. So we used to have a dev team, we used to have a QA team, we got rid of them both, and we all called them engineers. We used to also have manual testing, we got rid of them too. Why? Okay, we are very unique. We are a development team that writes software for developers, and we use the software that we write to create those tools. We are our own first customer. So when we need to do manual testing, we just use the software ourselves for 48 hours before you ever see it. What we do at Microsoft is something called safe deployment, which means we deploy the software to a production environment, and then if it passes the first production environment, we install it in another production environment that's bigger than the previous one. The very first production environment we install it in is called Ring 0. That is where the VSTS team actually works. So whenever 3 weeks happens, the very first team that gets the code is the team that wrote the code. And we use it for 48 hours. That means all over the world has had 2 full days of using it before we then give it to our customers, which means we've done all the manual testing. Not because we scripted it out, but because we did our daily job on that product for 2 days. So if you do not use your own software as part of your job, you probably still need a QA team, right? So that's what I told you. Don't go home and fire everyone unless you use the software that you're actually shipping like we do inside of Microsoft. So we're very unique in that particular instance, which is why we no longer have this. I just told you about the 27,000 unit test and the fact that we no longer have them and we want to mostly unit test. We do have a couple, like they're much smaller. We went from 27,000 to I think several hundred, right? It's drastically different. There are just certain areas that you're going to have to use a UI to be able to test, and we understand that. We also had to make sure that our tests weren't flaky. Has anyone ever had a test that passed, then it failed? You didn't change the code, and it passed again, right? That's called a flaky test. Something external to that test was what caused the test to pass or fail. Chances are you thought it was a unit test, but it clearly wasn't. Because if it was a unit test, nothing external could cause it to fail. And we had to go back in and we had to analyze our test and make sure that what we were calling a unit test was truly a unit test. We still do integration testing, you have to, but we also know when that's supposed to happen and we're no longer confused by that. But you want to find those flaky tests and try to eliminate them however you need to. We had to go to a principle of zero downtime. When you're running a system that's online 24/7, 365 days a year, there's never a good time to turn it off. Because even if it's dark in Houston like it is right now, it's like 3 or 4 in the morning in Houston, we're wide awake and getting ready to start our work today. So we can't turn it off at any time and not affect a huge portion of our customers. So what we had to do was figure out, how do you have a system that you want to update, but you can't take it down while you're updating it, because thousands, if not millions of people are using it, and they're not going to stop using it when you update it. Do you think your software could do that today? Could you take the software you write today and install it on top of itself while people are using it? We couldn't either at first. This goes back to the same point of we had to re-architect and rethink how our software is built and deployed to allow us to be able to deploy it while it's being used and never take it down. Again, architectural changes might have to be applied for you to move at this speed, because we had to do that because we can simply never take it down the way that it's actually being used. The freakiest thing of all is Ring 0, where we work, deploys itself on top of itself while we're using it. Right? It's not like there's something else installing our Ring 0 for us. It's the actual software itself deploying itself on top of itself while we're using it. It's just unbelievably complicated. But it's amazing technology, right, to be able to do those type of things as we deploy our software out. But VSTS deploys VSTS. It's fully automated. That was not always true. We had to work towards that. We used to have a Word document that explained everything that you're supposed to do to help deploy it. It was a manual process. And if you've ever tried to take a string from Word that has quotes in it and paste it into a command line, everyone laughing knows what I'm about to say. Those aren't quotes anymore. There's some fancy little character that PowerShell does not like, and all of a sudden, everything blows up on you. So it was a really error-prone process of people going in there and trying to fix the quotes and fix this, and that Word would mess up when you were trying to move it into a command line. We had to get out of that, so we had to make sure it was fully automated. We have a joint ownership. Remember that last chart I showed you of the engineering scorecard? That is dev and ops coming together to own the application deployment. The application is the goal, right? And whatever it takes for us to collaborate to get that done is what we do on our teams. Another thing that I thought was really interesting is the way that we decoupled our services. We have really clear contracts. Let's say, for example, I'm a microservice, you're a microservice, and you're a microservice. And the dependency tree is that order. That means you have to go first. If you're a new version, then you go, and then I can go. We've just complicated our deployment because now there's an ordering involved, right? It's not just deploying the software, it's deploying you first, and then me. But what if we could just deploy them in any order that we wanted? Life would be much easier, right? So that's exactly what we designed into our microservices. Again, it was something that we had to add. We had to make sure that no matter who depended on who, anyone can be deployed in any order, and they negotiate at runtime what version of you I should be using. But we have clear contracts. I know what version 1 looks like. I know what version 2 looks like. I want 2, but you're still at 1, no problem. I know what 1 looks like. I'll use you until 2 is available. Magic, right? But we had to rethink the architecture so that we could deploy at a much more rapid speed than we did before. Another thing that we use quite a bit is feature flags. We do not roll back on the Visual Studio Team Services team. Because whenever I talk about DevOps, the first thing people want to ask me is, how do I roll back just in case something bad happens, right? If you can't go forward, you going backwards, that's not going to work, right? It's simply not going to work. Going backwards is so much harder than going forward, and you couldn't get going forward right? So stop kidding yourself that you think you can go backwards. So we realized that and said, that's it. We got to start going forward and only go forward. So how do you go forward if you deployed software that's broken? You use feature flags. Because what you do is when you install the feature flag, you do that first, which means that code that you're writing is not even visible to anyone, but it's already in production. This is how we can merge into master every single day. If you have a feature that you want to deploy that takes 3 sprints to develop, historically what you would do is you would create a branch. That branch would live for 3 weeks by itself while master is changing. Then all of a sudden 3 weeks from now you would try to merge it back together and then boom, a big mushroom cloud would happen called a merge bomb, where all the merge conflicts simply made it impossible for you to merge the code together. So what we do instead is we use feature flags, which allow us to basically put the code in and merge it into master every single day because it's harmless, because the feature flag is off. That code can't be reached. As long as it compiles, it's good. And then what you do 3 weeks from now, when the feature is ready, is you just turn the feature on and everything lights up. If all hell breaks loose, you simply turn the flag back off. Right? So you don't have to roll back when you've actually built in and designed in this safeguard into the software using things like feature flags. Another thing that we use feature flags are big shows. For example, that 6 month at Build and that 6 month at Connect. A lot of the things that we want to show you have been in there for months, but we don't want you to see them yet. So we basically turn those flags off. We get on stage, Scott Guthrie says, and now we're announcing X, Y, and Z. We turn that flag on, and then everyone can actually see it. I can go on stage and demo it for you. It's really cool stuff. Again, all hell breaks loose, you just turn it back off. We wrote our own feature flagging because we did this 7, 8 years ago. You don't have to write it yourself anymore. You can use a product called Launch Darkly, which is a partner of ours, who actually will give you feature flags as a service, which is really, really powerful. So don't go roll your own. I encourage you to go investigate in them. Feature flags do not come for free. Every time I say feature flags, people get really excited. They are not unicorns that crap Skittles, okay? They're not for free. There's technical debt involved in feature flags, but the technical debt that you pay is far outweighed by the power that it gives you. We would never go back to writing software without feature flags, ever. But don't go into it blindly thinking that it's just going to be this silver bullet. They're basically if statements, which means your cyclomatic complexity goes up every time you add one. And then you multiply that when they're nested and things like that, okay? And you always eventually have to go back and clean them up. So the last couple things I want to leave you with are resources that you have inside of Microsoft. One of the resources you have in Microsoft is My Team. Some of you know us as the League. We're basically a collection of DevOps practitioners that span ops and dev. We span Windows and Linux, containers and app service, Jenkins and VSTS. You do not have to use VSTS to get to Azure. If you want to use Jenkins, we'll actually help you there as well. If you need us, you can get to us through this little hashtag here. This hashtag stands for our name, League of Extraordinary Cloud DevOps Advocates. It's like a bat signal because when you use it, what ends up happening is this cool little window lights up in our team room. So we know if you use that on Twitter, we get a notification saying, go read this person's tweet. And all 5 of us will go read your tweet. If we don't know the answer, we will reach inside of Microsoft and find someone that knows the answer and add them to that tweet for you. So if you're not on Twitter and you need our help, just create an account real quick, send out a hashtag with that in it, we will come read your tweet and we will help you. The other resources I wanted to share you with are some of the things that we talk about here on Channel 9. The story that I've told you is obviously much, much longer than 50 minutes or an hour that I'm taking right now. But right here, if you go to DevOps interviews, you can actually see 35, 45-minute talks with the engineers from the VSTS team that actually do the stuff that I'm talking about. You want to talk about how we do safe deployment? Manil Shah will talk about that. How we went from 27,000 automated tests to over 72,000 unit tests, which we run in like 15 minutes. Manil Shah is going to actually talk about exactly how we do that. You want to know how we keep the consistency in the UI and the architecture across 50 feature teams? There's another guest that I have called Aaron Bjork. He talks about that. So we basically go really, really deep into all the topics that I brought up in this particular talk on this show called DevOps Interviews. We also have the DevOps Lab down here on the right-hand corner. This show is really good because instead of talking theory like we do up here, we talk practical examples. Here's a problem. Here's exactly how you solve it using DevOps best practices. And then we obviously have Azure Friday for all your Azure information, and then we have the Visual Studio Toolbox for our Visual Studio fans. So I'm going to leave that up there for you. Again, if you need me, I'm at Donovan Brown on Twitter, and you can get to my entire team on the league. Thank you again for having me. Thanks. Did we have time for questions, or do you just want them to ask me questions outside? What would you like to do? Where's Max?
If there are questions.
Are there any questions anyone has? Because I'm more than happy to answer them. If not, like I said, you can ask them later on Twitter, or I will hang out. I'll be here probably for the next 20 minutes anyway, so you can just catch me outside as well. Oh, go ahead. Good.
What are the other teams at Microsoft doing, like the Windows team?
Great question. So the question is, what are the other teams at Microsoft doing? And I'm glad you asked that because everything that I just said is about the Visual Studio Team Services team in particular. So that's a very good question. Not about Xbox, not about Bing, not about Windows, not about Office. We're all on this DevOps transformation, all of us, but we're all at different stages. I would think Bing is probably the most mature, right? Because they were born in the cloud, they started in the cloud, they deploy multiple times a day, every single day. Actually, the VSTS team deploys multiple times a day too, but not new big features. What we do is bug fixes, hot fixes. We do that multiple times a day. But then every 3 weeks we do the big stuff. So the Windows team just moved over their work item tracking and their source control. Their source control in the Windows team is a 350 gigabyte Git repository. So big, in fact, that we had to invent a whole new file system just so that they could use Git. Because otherwise, cloning their repository took 3 hours. Doing a status took like 5 minutes. Right? A Git status should take nanoseconds, milliseconds. It took 5 minutes to do a status on your repo. So what we did is we invented the Git virtual file system, and we gave it back to the public. So it's in open source right now, so GitHub and GitLab and other people can use it. So Windows is on their way. Office is coming on next. Xbox is already there, because it was funny, Xbox team saw me do like a build keynote or something, and I got this email from the Xbox team saying, come show us how to do that. So I went and hung out with the Xbox team for a while, showing them how to set up continuous integration and continuous delivery and things like that. So the entire company is trying to get to one engineering system is what we call it, and that one engineering system is VSTS. So all the software for Visual Studio, VSTS, Office, Word is all in VSTS right now. So that's what we're doing. Okay, go ahead. Oh, how do you estimate? Estimating is an art, and it's not a science. Again, don't beat your people up. The best advice that I can give you for being good at estimating is only estimate things in 4-hour chunks. You'd be surprised, right? Because right now you probably have someone say, oh, it'll take me a week, right? And as a developer, a week sounds like a long time. Hell, I could write an operating system in a week. A week? Yeah, I got this, no problem. I can get it done in a week, right? But it's never a week, right? It's never, ever a week. So what I tell my engineers now is like, okay, great, you're going to be done in 5 days. Tell me what you're going to do every single day. And I want it in 4-hour chunks. What ends up happening is first they're going to be like, oh, come on, man. I told you it's going to take a week. I got this. Like, no. I want to know what you're going to do every single day. They're like, fine. So the first thing I'm going to do is this. Second thing I'm going to do is this. Next thing you know, they're on the 7th finger. Like, that's what I thought, right? So, and another thing that's really cool if you make them break it down is that you'll know if they forgot anything. Because if there's no task for writing unit test, because if they just say it's going to take a week, in your mind, you believe that they're going to do all the right things. They're going to write unit tests. They're going to do design. They're going to do everything. But you don't know. It's just a black box that says a week. But when you make them break it down into 4-hour chunks, you'll see them. You'll see the design. You'll see the unit testing. You'll see all this cool stuff. And if you don't see it, you can say, hold on. You're forgetting to write your unit test. Oh, yeah, let me add that task. And next thing you know, it's 8 days, 9 days, which is okay, as long as you know before you commit to the work, right? You don't want to commit to a 5-day task that actually is 2 weeks long. If you know it's 2 weeks going into it, it makes it much easier for you to do. So believe it or not, the easiest way to get good at estimating is stop letting people say it's going to take them a week. Make them break it down into 4-hour chunks or less. Because another thing, if you're an agile shop, what are you supposed to do in your daily stand-up? What have I gotten done since the last meeting? What am I going to get done before the next meeting? And is there anything stopping me? If you have a week-long task, on Monday, you say, I'm working on task number 1. On Tuesday, I'm working on task number 1. Wednesday, Thursday, Friday. I don't know until Monday when you say, I'm working on task number 1, that you fucking screwed up, right? Like, what are you talking about? You're supposed to be done on Friday, right? But if you have 4-hour tasks, you should get one of those tasks done every single day. So on day 1, I'm like, what are you working on? I'm working on task number 1. It's 4 hours long. Great. On day number 2, what are you working on? I'm working on task number 1. I immediately know something is wrong. I know on Tuesday that something is wrong, not Monday of next week. Let's go talk about why you're still working on task number 1. Is it too hard? Do I need to pair you with somebody? It's amazing. That little change will make you more efficient and more accurate. Make them estimated in 4-hour chunks or less. Anything else? Go ahead.
How do you handle database migrations with feature flags?
Yes, so feature flags are applied at all different levels, but it's a much more complicated answer than that. So what I'm going to do is that I'm going to get one of these guys to sit down with me because it's extremely complicated because we not only do things like schema changes, but data changes, right? Those data changes actually go out ahead of time, right? And we're massaging all the data, getting it ready for that front end that actually lay on top of it. So it's amazingly complicated. Brian Harry literally blew my mind explaining to me how we did this stuff. And I wish I had a camera when he told me that because I was like, holy mackerel. It's easy to add a column to a database, right? You can use SSTT, ready roll. But when you're changing the data on which your application runs, how do you keep it in sync with the old version and the new version, all that kind of stuff? I'll get one of them to explain it in much more detail than I can. But we do our database as part of our DevOps pipeline. That's the most important part. You do not say, oh, we're doing DevOps and you're deploying your front end. And then you have this dirty little secret where you go and run this little command by yourself manually. Like, oh, don't look over here. I'm doing our database. That's wrong, right? Everything should be in the exact same pipeline. Your infrastructure, your database, your apps tier, your mobile front ends, the entire thing. I did a demo at Techorama where I literally had a Xamarin and iOS application sitting on top of a web API, sitting next to a Docker container with a database backend, and I added a column to the entire app on stage, right? I pushed one button, and then everything simply happened, and that's what you want your pipelines to do, and that's what we do at VSTS.